In this lesson, I'll show you how you can use energy analysis techniques to solve calorimetry type problems. The first of two questions asks, a block of ice initially at 50 kilograms and traveling at 5.4 meters per second slides along a horizontal surface until it comes to rest. Assume that all the heat generated due to friction is used to melt the ice. How much ice is melted? To answer this question, you have to calculate the kinetic energy of the ice as it's moving. And what they're asking is, if all that kinetic energy went into melting the ice, how much of that ice would have melted? So we'll begin by calculating the kinetic energy, and the formula for that is shown right there. We have kinetic energy is equal to half times the mass, which is 50 kilograms, times the velocity being 5.4 raised to the power of 2. We can find out how much this is using our calculator. 0.5 times 50 times 5.4 to the power of 2. We end up with 729, which I'll round to 730 joules. Now all this energy is going to go into converting that ice to water. So there's a phase change there, and we'll be using the heat of fusion constant underneath, being 3.3 times 10 to the power of 5 joules per kilogram. That unit should be in kilograms. And just to note that the heat of fusion constant is normally much larger than that of the heat capacity of water. So how do we use 730 joules and this constant to find the amount of mass of ice that's been converted? Well, remember that if you take this value and multiply it to the mass, you should end up with a value that's in joules. So how much mass of ice will melt with 730 joules? All we have to do is divide both sides by this factor, and that will isolate for m, which represents the mass. Here's what I mean. So if I divide both sides by 3.3 times 10 to the power of 5, so again using our calculator, 730 divided by 3.3 times, and make sure that's in parentheses, the denominator, so 3.3 times 10 to the power of 5, that makes this many kilograms, 0.002 kilograms. If you want, you can make this into grams by multiplying it by 1,000, and if you do that, you end up with 2.2 grams of ice is converted with this much energy. Let's move on to question number 2. This should read grams. I've never seen a bullet that's 5.0 kilograms. A 5.0 gram bullet traveling at 800 meters per second passes through a 5.0 kilogram copper block at rest on a frictionless table. 20% of the kinetic energy of the bullet goes into heating the block. 30% goes into kinetic energy of the block, and 50% remains with the bullet. The block and bullet are initially 25 degrees Celsius. What is the temperature and speed of the block and the speed of the bullet? Alright, we'll start by finding the kinetic energy of the bullet using the same formula we used in question number 1, being half times the mass, 5 grams made into kilograms. That value needs to be in kilograms. So we will divide that by 1,000. We get 0.0050 kilograms multiplied to the speed of 800 meters per second to the power of 2. Using your calculator, you should get 1,600 joules of kinetic energy. Now 20% of that, so 16 times 0.2, let's see how much that is. 1,600 times 0.2, 320 joules will go into heating the block. To find out the temperature change of the block, we use the heat capacity formula. So I'll take this value and substitute it in for Q. That's the amount of heat or thermal energy. 320 joules is equal to the mass of the block being 5 kilograms multiplied to the specific heat of copper. That's given in the question as 390 joules per kilogram times degrees Celsius. And now we can calculate the change in the block heat. So we'll multiply these two values, then divide both sides of the equation by their product. 320 divided by 5 times 390 gives us a change in temperature of 0.16 degrees Celsius. So that's the change in temperature of the block. We just answered one part. So that part is gone. Now we need the speed of the block. The speed of the block can be calculated. Well, we're told that 30% goes into the kinetic energy of the block. So let's find out what 30% of 1600 is. That's 480. 480 is equal to, I'll again use the kinetic energy formula now to find the speed of the block. So I have half times the mass of the block being 5 kilograms times v to the power of 2. We're looking for its speed. So I'll find the answer to these and then divide both sides by that. 480 divided by 0.5 times 5, which is 2.5. That's 192 is equal to v squared. Then I square root, and I get a speed of 13.9. 13.9 meters per second. You can round that to 14 for simplicity's sake. So that's the speed of the block, and that's the change in temperature. The last thing that they wanted was the speed of the bullet. Well, 50% remains. So again, you have to use the kinetic energy formula, where if we take 50% of 1600, being 800, so the kinetic energy is 800, is equal to half the mass of the bullet, being 0.0050, times the speed. If we solve for v the same way we did in the previous calculation, you should end up with the speed of the bullet being roughly 570 meters per second. And there you have it. Now you know how to combine kinetic energy and calorimetry type calculations.